Hi, we're going to find the slope as a rate of change again, but this time instead of with tables, it's going to be from graphs and equations. So really pay attention to the units. So this first graph on number 1 talks about the cost of the spirit shirts. So first of all, on 1A, it says, what is the rise? So you're going to go from 20 to 40, which is 20, and then the run is 1. So what is the rate? Well, 20 divided by 1, so it's $20 per shirt. And then 1C, what do you think the $20 on the y-axis represents? Well, I think that it probably might be the startup fee, like for the design. So why don't we put the design on shirt? All right, let's go to problem 2. This one talks about the cost of lemon chills at the ballpark. So on 2A, it says, what is the rise? But first of all, we don't want to just go up 15 and then over because, that does look like it may go up 15 over 3. But let's make sure that it does go through an intersection. So that one really doesn't go through an intersection. So let's go on up, and it looks like this one does. So that means we're going to go up 30 and over 6, excuse me. So the rise is 30, the run is 6, so 30 divided by 6, so it's $5 per chill. This function represents direct variation because the graph goes through the origin. The origin is at 0. All right, let's take a look at problems 3 through 8 here. And it says the graph shows the relationship between the amount of water being drained from a large tank as a function of the number of hours that have passed. So what number represents the y-intercept? That is the 1,000. And what does it stand for in this problem? Amount of water. Amount of water. So that's the amount of water initially in the tank. How long does it take for the tank to get empty? Well, it goes down there at 20 hours. What would you call that point on the graph? Well, this is the x-axis, so it'd be the x-intercept. Number 7, what rate is water being pumped out of the tank? That's your slope. So you can do a couple things. I think you're starting here, and here's another intersection, there's another intersection. So it really doesn't matter. I guess you could go down 1,000 over 20. So a couple things I'll show you. So you can go down 1,000 and over 20. You could go down 500 right here. So 500 over 10. And when you write those two down, 1,000 divided by 20, if you divide each of these by 2, it goes 500 divided by 10. So then I'm going to divide that even more. I'm going to drop out the zeros. So 50 divided by 1 is 50. So that is the rate. So it is, the tank is being pumped out 50 gallons per hour. Now, when it's being pumped out, it's basically a negative amount because you're taking out 50 gallons per hour. So you're starting with 1,000 and you're taking out 50. So we need to look at an equation on number 8 that has a negative 50. So not that. And that's not a negative 50. The thousand's the negative, but you're not starting with a negative amount of water. So it is going to be answer choice B.